The next thing we're going to deal with is scientific notation, where we write things out with powers of 10, and the number is between 1 and 10, but not equal to 10. We will use scientific notation when we're working with very large numbers or very small numbers. Now, our calculator, what it considers large and small, is a little different. So sometimes when we put things in scientific notation, it will switch them over to ordinary notation because it does not consider them that small or that large. Here, we're going to take a look at some calculations with the distance to the nearest star. So what happens is we want to multiply some numbers out. So we end up taking 365 and a quarter days in a year times 86,400, and it switched it over to scientific notation. Then if we go up here and copy this number and take it times, 299, this large number, again, it switches it over to scientific notation. And we want to switch this over to kilometers. So then what happens, we divide by 1,000 and it switches it over. And if we go up here and press enter, it will show it out with all the different digits. So again, we can do these calculations on either model of our calculator. Where these calculations came from is there's 365.25 days in a year, 24 hours in a day, or 86,400 seconds in a day, and the speed of light, 299,792,458 meters per second in there. So that's where these entries came from. We like to use a notation where you put in a space instead of a comma between the digits, but our calculator does not use a notation like this. In fact, the calculator does not even put in the commas. Now, a real nice feature of the CAS calculators is it can do units of measure. So if we ask for a constant for the speed of light, it will tell us that it is this many meters per second. And then if we multiply this stuff out, it will keep track of the stuff in terms of units for us. It also has a way to convert from meters to kilometers directly without us dividing by 1,000. Let's go ahead on our calculator and look at some of these calculations. So let's go to our scratch pad and we'll go to our catalog and tab number 3 in our catalog. So we'll press 3 and it's opened already for constants. Let's close it and reopen it. This is the conversion operator that we use at the end. This is the constant that are built into our calculator. So if we go sideways, and this will be a constant for the speed of light. So if we're on this one and we press enter, and then we press enter, it comes up with our answer as meters per second. Notice the time sign in here. So what we want to do is we want to take this times this number here. So let's type it into our calculator. 31557,600. Now we can go up and get this unit in our catalog, but if we know it's going to be seconds, an easier way to do it is to use this key down here. So we'll press this key. We'll move over until we're on the underscore, press enter, and then put in S. Now again, we did it with an implied times. To be on the safe side, and when you're doing more complex operations that are fractionals, like meters per second squared, you will want to put in the times. But here we use the implied. Then we want to take it times this number right here, so we can go up, press enter, copy it down, and press enter, and it's going to turn out to be this number here. Well, you can see we obviously got in some trouble here, because this is not the answer we have here, and things are together. So this implied multiplication and stuff got us in trouble, because right here there's no multiplication symbol. So that's where this got into trouble. So let's go up here and clear this out and start over again on this part. So if we move up one and press delete, it will clear that part out. Then if we move down and retype it in, so we'll type in 3, 1, 5, 5, 7, 6, 0, 0. Let's type in the times this sign. Then underscore. So let's move over, get our underscore. Press enter. Put in seconds. Now this is actually where the mistake was, because we needed to put in the times. Then we'll put in the times. Then we'll go up here and copy this. Press enter. And then press enter and come up with the answer that we were looking for. Now to convert this answer over here, we'll go up here, we'll copy this down, we'll go to our catalog, we'll move up, we'll press enter and get the convert operator. Since we want to convert it to kilometers, we can again type it in ourselves, or we can use the catalog to find it. So we'll go into here, we'll move over to the underscore, we'll type the underscore, then we want to convert it to kilometers, okay, and we'll press enter and it will calculate this answer for us. Moving to the next page, we see something that bothers us a little bit, that when we type something in, it says true, and we type in the same thing, it says false. Well, what are we doing here? Well, what we have to deal with is when we start dealing with our calculator, it has fixed and floating point types of numbers. And so we have to take a look at that and the precision and so forth of our calculator. So let's go ahead and work these problems out on our calculator for a second. So menu, 1, 5 to clear that out. Then we'll bring up our template. We'll put in 1. We'll put in the square root of 3. We'll move sideways, get out of there, put in equal, and we'll again bring up our fraction template, put the square root of 3 in the numerator, put 3 in the denominator, and press enter, and it will say true. Now again, this kind of calculation here is a Boolean calculation. That's why it's going to come back true or false. So now we want to do the same calculation again. So let's go up here and copy it down. Okay, and press enter. Now, this is, okay, what we did on the CAS. On the numerical calculator, let's hit Control and enter. And this is where it came up with false. So when it's storing these numerically, it's saying that how this one is stored and how this one is stored is different. That's why the answer is false. When it's doing this with the CAS model, it's storing these and it turns out to be true. To take a better look at this, we take a look at the decimal approximations. 1 over the square root of 3, if we type it in through our calculator and then press enter, we come up with this number with a 2 in the end. Okay, and if we press enter, it just truncates it to the way our calculator is set. If we type in the square root of 3 over 3, it looks like they're identical, but if we press enter, we see that the last digit is different. That's why this turns out to be false. Now, we do have to pay some attention to what's going on. Earlier, when we typed things in, we typed it in with a decimal. Whenever we type in a calculation with a decimal, then the answer will be worked out as a decimal. Let's take a look at what happens when we type this in with a fraction. So when we type it, this calculation that we did earlier with a fraction, we get more digits. So again, our calculator can do a whole bunch of digits as an integer if we type it in as a fraction. Now we're going to be working in scientific notation and decimal notation, and there's all kinds of settings in our calculator. Well, there's 7 different fields, 7, 6, 5, all the way down to 1, and they all have a number that goes with them. So this mode operator gets what the settings are in our calculator. Without looking at some reference manual, this doesn't mean anything to us. But in a few minutes, we're going to write a program that's going to allow us to switch to scientific notation without switching the settings. Because if we had to, on every problem, switch the settings and set back, then it would be a hassle. So we're going to write a program to take care of that. We talked about switching numbers between decimals and integers. Well, there is a command called decimal that I can take this number and it will switch it over to a decimal. Well, since this number has more digits than is allowed with decimals, because the decimal can only store so many internal digits, it switches it over to scientific notation. Over here, we talk about the get mode command and go into it in a little bit more detail. Again, you can read the guide and see that kind of information. Where we're going to use it is we're going to write a program to do scientific notation. And again, you will want to take a look at this information, okay, in our guide to see what's going on. So we have to use the program editor, we have to call it a name, and then we have to type this into our calculator. Again, this was where the software version that comes with your calculator comes in handy, because it's easier to type this kind of stuff in to the software emulator and then transfer from the software emulator to your calculator. Also, one line got cut off. That was the end of the program line here when we were taking a screenshot of what's going on. And to work this problem out in floating scientific notation, we're going to use a 0. Anything else that we put in for the second parameter is going to get us to be in fixed notation. And then remember we talked about the modes. So here we had to set the mode and we had to set it to approximate for this to work. In this information before, we got the clue about how to do this kind of stuff on the web. There was another program that was written and to do a couple of these details, and we enhanced it to do this scientific notation. When you start doing programs like this, you will have to save this into your program library, and you will also have to store it. You will have to refresh it. So again, pay attention to steps in the guide to get this particular program into your calculator. Now, once we have it into the calculator, then we're going to be able to use it. Let's go ahead and look at the program in our calculator. So we'll go home. Then we'll go to My Documents, number 2. We'll move down to My Library. We'll press Enter. We'll go to Computer Learning Service Volume 1's Library. Since it works on both the numeric and the CAS, there's no extension on it. We'll press Enter. Okay, in here. Then we'll go to Control, over to 1. There's our distance from a point to a line. We'll go Control, move over to this one right here, and nothing is shown. Control, move over, and here's our scientific notation program. So let's go back over here, and you can see that things got messed up a little bit in our library because page 3 had nothing on it. It still will work correctly, but you can see that we need to actually delete the blank page, and then this will be page 3. And if I scroll down here, you can see the end of program statement that was cut off over here. So you can see the library here. Again, let's flip back to where we were. So if we put this calculation in with a fraction, and it's kind of messy, so we're going to store this intermediate calculation with the variable km. So we're going to go over a little bit later in this lesson. There's 3 different ways to store things. One way to store things is to type something in and hit the store button over here and then type in a name to store it under. So this was right here. Then if I call up my scientific notation program and I put in 0 to make it be in the floating mode, and if I put in the last parameter to be a 0, it will show all the digits for this particular calculation. Moving ahead, if I type a number times it, because it was too complex to type this whole thing in, put in 0 and 5, it will give me the answer that I want with the light years away. And then if I go up here and copy this and press enter, it will show that this is stored with 0. If I just take this calculation out here, okay, and press enter, it will show that all the digits are in here. So this is the advantage of using our scientific notation program. Okay, let's get sidetracked a little bit and put information together. In Chapter 1, we showed you how to add global functions. Now we just added this program for scientific notation, and earlier in this lesson, we added how to work with units. So let's put all 3 of these together. So let's go over to our calculator, go to the home screen, go to My Documents, go down here, and we have several different libraries we have added to our calculator. We added a physics library that only works with the computer algebra system. So that's why we labeled it this way. And we press enter. Okay, now if we go to our home screen and if we go to current in here, we see some calculations in this particular library going on. So let's scroll up for a minute and let's take a look at a global function that we added to this calculator. So this global function that we added to the calculator had to do with Newton's method for doing universal gravitation. And what we kind of like to do is when we name functions, we kind of leave out the vowels. That way the function name isn't quite as long. And the parameters are going to be, there's going to be a force, there's going to be two masses, and then there's going to be a distance between the two masses. If you use polar coordinates in math instead of Cartesian coordinates, and we haven't even really talked about any of that, when you use polar coordinates, you go a radius of a circle and you go an angle. So when we're dealing with the distance, that's why sometimes it's labeled with the letter R. If we move over here, so again, what we did was we used our live pub. Remember, we went to our menu, we went to our actions, we went to our library, and then there was the live pub show in the catalog. We don't want to redo it, so we'll escape out of there. So that's how we came up with this. Then we typed in the name of our function and we typed in the parameters. Now the formula, if you look in a physics book for doing this, we're going to use the solve command, which we didn't use before. The advantage to the solve command is any one of these variables can be missing and we can use this function to solve for it. That's why we use the variable x even though it's not in the formula. So now our formulas will not do upper and lower case, but this is the constant from the constant library that's involved in this particular one. So the force is equal to the constant from the constants library times the two masses over the distance apart, and then solve this for R. So we've added this to our library, and then we must refresh it. Now what happens is this constant has a whole bunch of digits. When you start working problems out, lots of times textbooks won't have that many digits. So we can build in our own constant if we wanted to. Remember, we talked about how we could store variables with this control store. So we put in the constant to not have as many digits as 6.67, enter exponent, negative 11. Then we put in the times. Then we use the control and the fraction template, and we put in our underscore using this key, meters cubed, underscore kilograms, we move down to the denominator, then times, underscored x squared, and stored this here. And so it wrote this in here. And if we move down, we added this formula, we put a 1 by it, and we actually used our constant. So when we start working these problems out, we can use the built-in constant, or we can use the constant that we added ourselves. Now the advantage to using the constant we added ourselves is when we're looking at our textbook, if it uses less digits, then we want to come up with the same answer that's in our textbook. Okay, storing functions and storing variables in our calculator, there's several different ways to do it. So the one way is to use, okay, the store, the arrow. Another way is to do it like computer languages, like the language Pascal used to have, when you were defining something, a colon and an equal. So this will do the same thing as our caret, except then the sides are reversed. So here I was storing the gravitational constant for the Earth, okay, in the metric system to be 9.8 times meters per second squared. Again, put in the time sign, bring up your fraction template and put those in. Then a third way to do this stuff is if you go to menu and you go to 1, there's the straight define as option number 1. Again, I'll escape out of this. So you can do it with a colon equal, you can do it with these flipped over in the store, or you can do it with the define. All three of these ways work for putting in a variable or putting in a function. Now, when you don't say live pub or live private, then this okay, variable and this function is only available when this is called up and this is working. So the advantage to this is that these same variables can be used in other problems and they won't interact. The private variable is not available in the catalog, but if you know its name, it's available on other pages and other problems. But variables and functions define this, any one of these three ways, colon equal, define, or the store, are only available directly inside of here. Now, when you actually type stuff in wrong and you want to get rid of it, if you go to your catalog, and if you go to option number 1, and you go down here, there's a command called delete var. So I'm going to escape out of it. So I typed some stuff in here and I used wrong names and I wanted to get rid of it. So if you call up the var when you're working problems out, it will show you what things are in existence at this particular point. And then if you put the name in after delete variable, it will get rid of this variable. If you just clear it out, it's still going to be there. So you have to use this delete var. So again, that's a little tricky. Here, I was defining this in terms of a system called dynes instead, in terms of grams and centimeters and seconds. Our current system is called the SI system. In the old days, it used to be called meters, kilograms, and seconds. Now again, if you define constants this way for the force of gravity, as I was defining a constant here, then it'll be calculated like this. The problem comes in is the calculations today are mainly done in the new SI system. Okay, and so you probably don't want to use this kind of system. I also tried to put in the English system, which is 32 feet per second squared. Again, I made a mistake and forgot to put the underscore. So if you redefine a variable after you define it one way, it will then oversee that particular one, okay, in there. Now, when you start working stuff out, the bad part was I started using this constant. I took it times 100 seconds squared, and even though I put it in with feet, it converted it over to the SI system. So you're doing stuff with the SI system. Okay, well, let me stop for a minute and load in some programs where we actually use this. Okay, I've loaded in my supplemental program for this particular chapter. So again, I wanted to show you the units of measurement. So if we took a rectangle that was 3 meters times 4 meters, we would get 12 meters squared. So again, in physics and so forth, you really want to work stuff out with the units involved in your answer. Now again, this is only going to work on this CAS calculator. If we were taking force equals mass times the gravitational part, so if we took 1 kilogram times 9.8 meters per second squared, again, notice the times in here and notice how we put in the unit using a fractional one, it converts it automatically over to 9.8 newtons, okay, in here. Now, if I use the built-in constant, G, and multiplied it out, it said this answer was 9.80665. So again, you probably want to store this constant under G if you're doing calculations like they're in the textbook, rather than to use the built-in constant, because you notice you get two different answers. I was also using the English system of 32 feet per second squared, so I was converting 32 feet over to meters. And when I started working problems out like that, it converted over to the metric system and used 9.7536. So you can see that the 9.8, 9.80665, 9.7536, when you're working in physics, there's slightly different constants when you work these problems out. And when you're on different places of the Earth, this varies because of your distance from the center of the Earth, but most of the time it will be very, very close to 9.8. And our calculator used this built-in 9.80665 for its constant right here, as you can see. Let's see what else I have here. Okay. Then the constant that we added to that formula that we showed you before that had to do with the gravitational constant was given as 66738 e to the minus 11 times this particular value. The one that we put in, that we stored, was 6.67 because that's the one that the textbook used to work out problems. Again, when we store it ourselves, we have to add the same units that are into the built-in. So we must add this particular. We could have used defined and say GC equal to this. We could have used GC colon equal to this, or we could type it in and use this store. When we used to use previous models of the calculator, we used to use this store a lot. So we have a tendency to use it where most people would use the colon equal or the define. Probably be better if we actually use the define, so that it's similar to library public and library private. So you'd have all three of them going on. So that's what we put in there. Then if we go to the second page and take a look at these particular problems that we worked out, we can see we called up our scientific notation program. Then we plugged in the variable that we were looking for, and we said give it to us with all the different digits, and it said the answer was 0. Then next we worked out the program here. We used the 1, which used our 3 digits. Here we used the built-in 1 to work out the program, and we see we came up with a slightly different answer. So again, we wanted to show you this stuff with different answers. But this is really handy because we can use our scientific notation program with our function program to get how many digits we want when we start working all the different problems out. Okay, and so that's where we put everything together into one and work that out for us. Okay, so that comes in really handy. So to do that, what we have to do, we have to go to catalog, we have to go to option number 6, we have to bring up our scientific notation program, which is under Computer Learning Service Volume 1, and we bring up our scientific notation program, which is the third one in this particular library. And then we have to bring up the formula that we want to use. So again, we're going to go to catalog. We're going to go down here to our physics library. And it only works on the computer algebra system because we use the solve command, and that doesn't exist in the other one. And there are 2 programs, the one using the built-in constant or one using the constant that we added. So say we use the constant that we added, we'll bring it up. Now at this point you must put in the parameters, and then after you put in the parameters you must go over to here. We want it to float, so we put in 0, and we want how many digits we want. Okay, so if we wanted 5 digits or 3 digits in our answer, we put that in, and then we press enter. Here we didn't add any parameters, so it's not going to give us a correct answer. Let me finish by just looking at the rest of the screens in this particular chapter. So here we see it's using the scientific notation with just numbers built into it, and we see it's working problems out. We then add another program to do decimal notation, so to switch it back the other direction. So this program's in there to go the opposite direction of the scientific notation. Now, the one problem with the decimal notation program is how our calculator does stuff. So here we put it in scientific notation with a small number, and it converts it over to a decimal. Here, when we put the number in scientific notation and pressed enter, it converted both our input and our output. So we don't see it, but it actually worked out for us directly. So that's the end of this particular chapter.